Hello to everyone, I'm Antonio Famiglietti from Carlos III University of Madrid. I'm going to present a work about a new linear concentrating solar cooker, its design, construction, and experiment. Concentrated solar cookers have been used since many years for cooking food, and there are several examples of concentrated solar cooker. The most common one perhaps is the parabolic dish, which is widespread solar cooker. But also recently, a few examples of linear concentrated solar cooker can be found on the market. We have several examples nowadays available. They use the principle of optical concentration as well as parabolic dish, but they are much more similar to a parabolic trough collector, which is normally used for providing for producing energy. In fact, they have a parabolic reflector, and in the focal point of the parabola, they have a linear receiver, which is in this case used for cooking. So in all of these commercial application, the receiver is an evacuated tube, which is an high efficiency tube with very low thermal losses to the ambient, and so it allows to cook food with a reasonable temperature and with good performance. But of course, this evacuated tube is not easy to find when one can obtain a linear concentrated solar cooker using only low-cost materials. So in this project, we try to design a new linear concentrated solar cooker which use only low-cost and simple materials, and aiming an easy manufacturing. And also, thanks to the original design, we can obtain a comfortable cooking. So we start the design of this solar cooker from the receiver first, which is being obtained using common cooking tools. As we can see here, we use some rectangular molds, which are common molds using for conventional cooking. And they have been encapsulated inside a box, as we can see in this figure, a box which is built using wood, an external layer of wood, and an internal layer of insulating material, in order to allow the concentrated irradiance to hit the molds from the bottom part, entering across glass, which reduce the thermal losses to ambient. On the upper part, we also use a cover, which is also made of insulating materials, and the cover is removable in order to allow to introduce the food inside the solar cooker and also to easily manipulate. Also, in the inner part of the box, we put some reflecting material which allow to refocus some of the radiance which miss the molds, to refocus it on the molds in order to increase the optical efficiency of the solar cooker. We can see here a 3D view of the solar cooker and all the components we use for building the receiver. The design of the collector have been made using parabolic profile, as we can see in this figure, but we only use half of parabola in order to concentrate the sunlight, the incoming sunlight, only to the bottom part of the receiver, so it can enter inside the insulated box. The dimension, the size of the parabola, the focal length, and the aperture have been chosen according to the size of the whole solar cooker, especially according to the height of the receiver, which must be which must allow a comfortable cooking, as we can see here. And on the other side, the parabola must be orientable in order to track the sun, even if this is done manually. But as we can see, it must be able to capture the solar irradiance with high angles or with lower angles, as in the morning, in the afternoon, typically, or in the winter season, for instance. So here we can see some step of the construction of the receiver. We first prepare the pieces for building the box, the wood-made box. Here we can see the cooking plane, where we introduce already the molds, and here the assembly of part of the box. Here, this is the lower part of the box. We can see the thermal insulation we introduce inside, and the reflective element that recover the concentrated irradiance missing the molds. Finally, we cover with the glass. Here we can see the construction of the cover elements, which are obtained from a wood box filled with insulation materials, and they are fixed on the cooking plane, as we can see here. They can be opened and closed when cooking. We obtain the collector from a wood profiles, as we can see in this picture. We create a structure for the support, and then we fix on it the reflecting layer. On the other side, we can see the support structure, which have been built in order to fix on it all the elements. And here we can see as the collector is fixed on the structure and can be oriented toward the sun in order to track the sun. Here we can see the picture of the solar cooker ready for cooking. We can see as the collector is orientable, and the object is ready for cooking. So we perform some tests in order to characterize the behavior of the solar cooker. So we first try the solar cooker with the molds empty, so without any material, any food, in order to see the maximum temperature reached by the solar cooker. Then we can see, as in a few minutes, the wall of the mold reach 200 degrees or more, and we also measure the temperature of air inside the molds. Then in a second test, we fill the mold with an amount of oil, with sunflower oil, half liter, and we see the evolution of the temperature of the oil as well as the temperature of the mold. We can see as we get almost 225 degrees in 1 hour, more or less. The third test is made using water. We fill the solar cooker with 1.5 liter of water, and we can see as we get the water boiling in less than 1 hour. So finally, we use the solar cooker to cook some food. So we try a different type of food. Here we reported some eggs fried. Also, we try to cook meats, as you can see in this picture, hamburger and bacon and others. And also we prepare rice. and also a tomato soup. As we can see, the solar cooker allows to cook two different food at the same time, and then eventually to mix them. Also, the mold is can be extracted from the solar cooker and can be cleaned easily. It's able to boil water, to bake also brown food, and also pan fry and fry slightly. So here we can see we have some video which show better the the shape of the solar cooker and its working principle. We can see now is concentrating on the bottom of the receiver. Here we are trying the solar cooker empty. We are measuring here the temperature of the mold as well as the air inside. On the other video, we can see also the solar cooking operating. In this case, this boiling water. Of course, it has better performance when the cover is closed. And in this case, we see again the solar cooker operating. In this case, we are cooking some tomato soup. So we can see this boiling slightly. And on the other side, we have some rice. So the new solar cooker, which is proposed in this study, have been designed, built, and tested. And the main focus of this work was to get a solar cooker which can be easily manufactured using low-cost materials and materials that are available all around the world. And the special shape of this solar cooker allow comfortable cooking. So according to the test performance, it can boil water in a reasonable amount of time and can be used for cooking several kind of food with reasonable time. Thank you for your attention.